According to the National Electrical Code, specifically Article 430, it is generally not permissible to place three separate 2 horsepower 208-volt single-phase motors, each with individual overload protection, on the same 20-amp circuit using number 12 wire. This determination stems from several key considerations outlined in Article 430, which governs motor circuit. Firstly, conductor sizing for motor circuits is crucial. Section 430.22 typically requires branch circuit conductors supplying a single motor to have an ampacity of not less than 125% of the motor's full load current, or FLC. The FLC for a 2 horsepower 208-volt single-phase motor can be found in NEC Table 430.248. Let's assume, for the sake of example, that the full load current is approximately 10 amps. In this case, the minimum conductor ampacity would be 10 amps multiplied by 1.25, which equals 12.5 amps per motor. Secondly, when dealing with multiple motors on a single circuit, Section 430.53 comes into play, but it has specific requirements. While it does allow for multiple motors or a motor and other loads to be connected to the same branch circuit, it requires that the branch circuit short circuit and ground fault protective device be sized appropriately. This sizing is based on the sum of the full load currents of all the motors, plus any additional loads, and also consider the largest motor. The code provides methods for calculating this maximum overcurrent protection. Thirdly, the overcurrent protection must comply with Section 430.52. This section dictates the maximum rating or setting of the branch circuit short circuit and ground fault protective device. This is often a fuse or circuit breaker. For motors, this overcurrent protection is typically significantly higher than the conductor ampacity to allow for the motor's inrush current during starting. However, there are limits. For example, inverse time circuit breakers are often limited to a maximum of 250% of the motor's full load current, while fuses can sometimes be higher. Fourthly, number 12 wire, according to NEC Table 310.16, typically has an ampacity of 20 amps when using the 60°C column, assuming it is installed in a typical raceway or cable. This is important because you need to check the allowable ampacity based on the conductor's insulation type and termination temperature ratings, as well as the ambient temperature and the number of current carrying conductors in the raceway. Fifthly, with 3 motors, each requiring a minimum of 12.5 amps of conductor ampacity individually, the total ampacity required for the motors alone would be 3 multiplied by 12.5 amps, equaling 37.5 amps. This already exceeds the 20 amp rating of the number 12 wire. Sixthly, while individual overload protection is provided for each motor, as stated in the question, this overload protection does not protect the branch circuit conductors from overcurrent caused by multiple motors running simultaneously and drawing more current than the wire is rated for. The overload protection is designed to protect the motor itself from damage due to excessive current draw, not the branch circuit wiring. Seventhly, even if the motors do not all run simultaneously, the NEC requires the branch circuit conductors to be sized to handle the potential load of all motors running at the same time. This is because it is reasonably foreseeable that all 3 motors could be operating concurrently. Eighthly, NEC 430.53 addresses situations where you have multiple motors on a single branch circuit. It includes specific conditions that must be met, such as the rating of the overcurrent device and the individual motor overload protection. If the overcurrent device trips under normal starting and running conditions, it indicates that the overcurrent device is not properly sized for the application. Ninthly, it's crucial to understand the difference between overload protection and short circuit and ground fault protection. Overload protection, provided by devices like thermal overloads and motor starters, protects the motor from sustained overcurrents that could cause overheating and damage. Short circuit and ground fault protection, provided by the branch circuit overcurrent device, protects the wiring from immediate and dangerous overcurrents resulting from faults. Tenthly, the NEC mandates that all electrical work must be performed in a neat and workmanlike manner, according to Section 110.12. Overloading a circuit and using undersized conductors is a clear violation of this requirement, as it creates a potential fire hazard and compromises the safety of the electrical system. 11thly, local amendments to the NEC may exist. Therefore, always check with the local authority having jurisdiction, or OJ, to ensure compliance with any local electrical codes or regulations that may be in addition to or different from the NEC. 12thly, consider voltage drop. Although not explicitly mentioned in the initial question, voltage drop can become a significant issue when running multiple motors on a single circuit, especially over longer distances. Excessive voltage drop can cause motors to run inefficiently, overheat, and potentially fail. The NEC recommends limiting voltage drop to a maximum of 5% for motor circuits. 13thly, the specific type of motor and its application can influence the electrical requirements. For example, motors used in critical applications, such as fire pumps or emergency systems, may have stricter requirements than general-purpose motors. 14thly, the calculations for motor branch circuits can become complex, especially when dealing with multiple motors, different motor sizes, and other loads on the same circuit. It is always recommended to consult with a qualified electrical engineer or electrician to ensure that the circuit design meets all applicable code requirements and is safe and reliable. 15thly, it is important to consider future expansion. If there is a possibility that additional motors or loads will be added to the circuit in the future, the circuit should be designed to accommodate the increased load. This may involve using larger conductors and a higher rated overcurrent device. 16thly, the NEC is not a design manual, but a minimum safety standard. Following the NEC ensures a safe installation, but a well-designed system often exceeds the minimum requirements to provide greater reliability and performance. 17thly, when selecting conductors for motor circuits, it is important to choose conductors that are suitable for the environment in which they will be installed. For example, conductors used in wet or corrosive environments must be specifically rated for those conditions. 18thly, the use of energy-efficient motors can reduce the overall current draw and potentially allow for smaller conductor sizes and overcurrent protection. However, it is still important to perform all necessary calculations to ensure that the circuit meets the NEC requirements. 19thly, proper grounding is essential for motor circuits. The grounding system provides a low impedance path for fault currents, which helps to quickly trip the overcurrent device and prevent electrical shock hazards. 20thly, regularly inspect and maintain motor circuits to identify and correct any potential problems before they become serious. This includes checking for loose connections, damaged insulation, and signs of overheating. In conclusion, based on the NEC requirements for conductor sizing, overcurrent protection, and the combined load of 3 2-horsepower motors, it is generally not permissible to place all 3 motors on a single 20-amp circuit using number 12 wire. The conductor ampacity and overcurrent protection would likely be insufficient to handle the combined load, potentially leading to overheating, nuisance tripping, and safety hazards.